Hello, everybody. My name is Sebastian. I'm here with my wonderful teammates, Chloe and Annabelle, and today we'll be going over some of the work that we did with the Canada Energy Regulator over this past summer. Just to give you a brief overview of what we'll be talking about today, we'll talk about who the Canada Energy Regulator are, some of the data sets that they provided us with, some of the models that we were able to run, and some of the conclusions and analyses that we got from the data as well. So the Canada Energy Regulator is a federal agency that overviews the life cycle of energy-related projects that cross provincial, territorial, or international borders. Through their regulation of the life cycle of these projects, they have amassed a really large amount of text data related to a lot of different topics. So the social, environmental, health implications of a lot of energy related projects across the entire country. However, the issue is that a lot of that data is really hard to access because people at the CER have to read it and manually label it. And because of that, some of that really valuable knowledge is really hard to access for members of the general public, but also for the CER itself. So our goal for the summer was to build a series of models that could emulate some of the labeling that the CER was able to do on its own. We were provided with 2 data sets. Just to briefly talk about the implications for social good itself, of course, the primary beneficiary of our project is going to be a CER, because we'll be able to provide new insights and some of the data they provided to us. We're increasing their ability to search and understand what this text means and what it contains, and we have the potential to save some costs and some time for them. But the general public could also beneficiate from this project, specifically First Nations, Métis, and Inuit nations and communities. Some of their knowledge has been captured by the CER, and it's hard to reach for them, and so it's very important to be able to give this knowledge back. However, there are specific stakeholders like industry or NGOs that might benefit also from having access to specific types of documents going forward. And so those are some of the implications. We'll go over some of the data sets as well that were provided. Currently, the Canada Energy Regulator is reviewing their onshore pipeline regulations. They've been in place for a couple of decades already. And so they open up at least questions for the general public to provide responses to. And we're given some of those responses. We're given the organization that replied to those questions. However, all the data was de-identified, so we didn't have access to who specifically was replying. We were given access to the question that they were replying to, so the question number, the question text, the response. So all of the data that we have is at the response level. And as well, the CER manually labeled some of these entries. So we have the themes that they were labeled with. It's worth noting, as you can see in this example, that this individual entry, even though it's one answer, it has 3 themes. Just to give a bit more detail about the OPR dataset itself, 97 organizations replied to this set of questions that the CER posed, providing a total of 1,519 answers. About 80% of the answers that were in this dataset were provided by Indigenous organizations. The next most frequent organization was industry. There were a total of 23 themes that could be labeled for each individual answers, and the number of themes that were tagged per answer ranged from 1 to 13. On average, about 4 themes were labeled per answer. So already we're seeing a one-to-many relationship between entries and themes. And we're looking at a multi-classification issue because each individual entry could have more than one theme. In terms of the distribution of the themes as well, it's worth noting that there was a really strong positive skew. And by that, I mean that there were a few entries that had a lot of instances and a lot of themes that have close to no entries. And so we struggled to find some of the themes and some of the patterns in some of the smaller themes because it was harder to have enough power to analyze them. As well, something that's worth noting here is that there was a little overlap between themes. So on the x-axis, you're going to see a list of themes that were quite frequent, and on the y-axis, you're going to see the proportion of answers that mention that theme that mention another. So you're seeing, for example, that 48% of the answers that mentioned reconciliation also mention engagement and communication. And 72% of the answers that mention engagement and communication also mention reconciliation. So not only do we have multiple themes per answer, but we can see that a lot of the themes that were very frequent coincided. And so we're seeing a lot of intersectionality there between our ideas, and that kind of complicated the way that we try to model these individual themes and predict them.
So that was our first data set, and our second data set is called the conditions data set. Just as some background information, conditions refers to the project-specific requirements that CER places on companies that companies have to fulfill in order to be able to construct, operate, or abandon a project. And so these conditions are set in place by the CER in order to prevent harm, promote safety, and protect the environment. So just looking at a subset of the data, we can see some columns that tell us about project specifications like the company involved, the project name, project location, and of course the condition itself, and then a CER labeled theme. And so just like the OPR data, we want to be able to take the conditions text and build a multi-label classifier, since one condition can have one or multiple themes associated with it. And so as previously mentioned, the conditions dataset is separate from the OPR dataset. So OPR dataset had 23 themes and conditions dataset had 13 themes specific to this dataset. While OPR had a lot of overlap between the themes, it's important to note that the conditions dataset had around 71% of them labeled with only one theme. That being said, this is still a multi-label problem since one condition can have up to 6 themes. And so there was another distinct issue or distinct characteristic of the conditions dataset, and that's that it required a lot more text cleaning since it contained French, some French entries, some HTML tags, and some of the conditions weren't labeled as well. And there was also some unique issues with non-duplicate data. So just going into a bit of the cleaning that we did for the conditions data set, we started off with 23,812 rows. There were some adjustments we had to make to it, like removing any instances of the theme standard condition. After talking with CER, we noticed some inconsistencies with the label, and they advised us to remove it from our consideration for our models. We also removed any rows with missing data or missing themes, as well as rows that contained French. So after cleaning that up, we also removed any duplicates, either exact duplicates or non-exact duplicates. So for non-exact duplicates, we applied some fuzzy matching by calculating the similarity between different rows. So as you can see at the bottom, for example, we have 2 conditions that are almost identical, but except for the last 2 words, which are switched. And so we identified these and removed them from the data set, ending up with 2,897 rows. So here's a visual on the class distribution of our conditions data set. It looks quite similar to the OPR datasets distribution. We can see that our top theme has 1,178 instances, while our bottom theme has only 25. So we can see that it's just like OPR, it is a highly unbalanced data set. So I'm going to go into some of the models that we trained. One of them being a large language model called Bert. So just a bit of background, but a large language model refers to a language model trained on a lot of data. In Bert's case, it was trained on around 3.3 billion words from corpuses like the entirety of Wikipedia or Google's book corpus. And so we took this pre-existing model that was trained on all these corpuses and fine-tuned it to our specific task. So we fed the model some of our data along with the CER labels so that it could modify its internal parameters to be more to be able to work for our task, which is the multi-label classification problem. And so why would we choose, or why is Bert good for our problem? LLMs in general have a lot of success with noisier and or smaller data sets since they're able to leverage a large corpus that has been trained on. And as well, Bert compared to another model like GPT just generalizes better to this text classification problem. And so when we're feeding our data, there isn't a lot of pre-processing needed or a lot of cleaning needed. We just needed to remove our duplicates so there's no data leakage between our training and test sets.
We also looked at 2 statistical models. The first was a random forest classifier. Random forests work by fitting many different decision trees on a subset of the problem. So you take a bit of the training data you provide and fit a tree to it and do that a bunch of times. And then when you combine the results of all of these trees together, you can hopefully get a result that's more generalizable and less overfit to your training data. We also looked at a one versus rest logistic regression model. There's kind of 2 parts to this. First, one versus rest. Since our problem is multi-label, one versus rest trains a classifier for each topic that you provide it. that will identify either the presence or absence of that topic. So in the example of OPR, we've trained 23 different classifiers, and each one will recognize whether or not a theme like reconciliation is present or not. Logistic regression is a way to use linear regression on classifier data. So you take a linear regression line of best fit and then apply a sigmoid function to that so that you can use it in a binary like yes or no situation. Statistical models require a bit more pre-processing than something like Bert because they don't benefit from context like tenses or space stop words in the same way that Bert might. So to pre-process for these models, we first removed stop words, numbers, punctuation, and HTML. Then we lemmatized our data. What that means is if you've got a plural or different tenses of a word, you kind of remove that to get the base word so that you just get like kind of the core meaning of it. We then applied a TF-IDF vectorizer to our words to convert them into a numerical matrix. TF-IDF is a statistic that reflects how important a word is within a document or within a collection of documents. And so we use that to convert our text to numbers so that the models can interpret them and work. These are the parameters for our 3 different models. I'm not going to really talk about them, but if you'd like to take a look, we have them here. Then Annabelle will go over our results.
So I'm going to go into some of the results for our classification models. First, we have the OPR dataset. Just before I get into the results, I'm just going to say precision refers to how often the model is correct when it predicts a label, and recall tells us how many of the labels that CER assigned is the model able to identify. And so on the left-hand side, we can see all 23 themes. We can see that Bert has pretty poor metrics for this, but moving to the top 5, the model for the top 5 most frequent themes, we can see that Bert does a lot better and is almost comparable to our logistic regression. But overall, we can see that our models don't do too well with the OPR data. But looking at our conditions data, we can see that overall higher results than for our conditions data, we have overall higher results than our OPR data. And the results are quite comparable between our models and between our model for all 12 themes and then our top 4 themes. We can see Bert in this case doesn't do as poorly as it did with OPR, but it is quite comparable to the logistic regression results. And so going into the pros and cons of these different models, we wouldn't necessarily recommend Bert as the be-all end-all, but one of the advantages is that with other data sets, it's possible that it performs better on less data because it's able to leverage its large corpus of background information. And this is important when you consider CER's future data sets and all the time that might be needed to manually label them. And so that being said, there is also the limitation for Bert of its 512 token limit, which means that it will only accept 512 words for each, for example, for each condition. Anything past that, it won't consider in the model. And as well, the other limitation is that Bert is quite computationally expensive, so it's not easy to run all these models quickly, and they require a lot of computational power as well. That being said, the statistical models are very simple and easy to set up. Their training don't take a lot of time as well. And as we showed in the previous slides, their performance are comparable or better than our Bert models. And so just one of the limitations, or one of the things to consider as well, is that statistical models require a lot more pre-processing, and depending on the pre-processing chosen, our model performance can be affected.
So after we completed our classification models, we wanted to explore alternate ways of evaluating our themes to see if there's anything we could do that was maybe unsupervised that would also provide useful information to CER. We did this using Bert Topic. Bert Topic is an unsupervised natural language processing technique that sorts a text corpus into groups of related topics, leveraging Bert's embeddings. We used Bert Topic on the OPR dataset, and we looked at 2 specific purposes. First, we wanted to see if there were any potential new clusters within the data set. First, we looked across the entire data set, and then we also checked within specific themes. And we also wanted to explore the relationship between BERT topics document assignments and the CER assigned themes. Going more into that first point about potential new topics, first we looked at all of the data. Doing this, we realized it was really difficult to map specific themes created by BERT topic to CER defined themes. This is likely due to the multi-nature label nature of the problem. As Sebastian mentioned at the beginning, our documents had an average of 4 labels per document, and BERT topic can only put any given document in a single theme. So we noticed there was a lot of overlap in keywords. So maybe a document would have keywords that looked like it corresponded to 2 or 3 of the specific CER themes, but it was kind of difficult to parse out any like relationships past that. We then looked at specific themes. The way we did this is by just taking the subset of documents that had been labeled by CER with that theme. We looked at reconciliation, engagement and communication, and environment. And you can see on the screen here the intertopic distance map for the reconciliation theme. This shows the kind of general size of our different topics and their relatedness by how close together they are. One specific thing I'd like to point out is the little cluster in the bottom corner with Métis and MNO and regions as some of the keywords provided by BERT topic. This is really interesting because it kind of points to maybe a difference in questions or concerns or considerations of the onshore pipeline regulations from Métis nations compared to other indigenous groups or First Nations. Some limitations of BERT topic, it does require a quite large sample size to work. We noticed that on the environment theme, we couldn't even run BERT topic because there wasn't enough data. And environment is the 4th most common theme in the OPR dataset. So that just kind of speaks to how much data would be required to make this a viable option. It's also sometimes difficult to interpret. Some of the larger groups here, I haven't noted any specific keywords. That's because the keywords identified were kind of words that weren't super useful, like and, the, of, or other stop words. However, we noticed that removing these didn't really improve our interpretability at all. So there's not really anything you can do at that point because those keywords don't mean anything and removing them doesn't provide us more information. There's also a lot of inconsistency between runs on BERT topic. So this is a screenshot of a single run, but if we tried to retrain the model on the same exact data, we would get a totally different graph because there's no way to like set a seed or save the model parameters that provided us this.
As Chloe mentioned before, we were also interested in understanding if there was any kind of relationship between our unsupervised approach, which was BERT topic, and our supervised approach, which was BERT. And so initially, we took out 2 specific subsets from the first run of BERT topic that was run across the entire data set. Whenever BERT topic is not able to classify an entry into a specific group, it will label it as unclassified. And so we took some of those entries for the top 5 themes specifically. And we also looked at the bottom 5 BERT topics for the top 5 themes to see if those individual on kind of rare BERT topics were different from the general topic in some kind of way, in some kind of pattern. And after having those 2 different subsets, we then rerun our BERT model to try to see how good was it at identifying the initial CER theme. So what you're seeing on the far left there with a disagreed and agreed is how often did our BERT model agree or disagree with the CER label themed. And then on the left, what you're seeing with unclassified or rare are the sources for that specific entry. So was it from BERT topic rare within the top 5, or was it for BERT topic unclassified for the top 5? It's worth noting that the accuracy, kind of like the percent that agreed between BERT and the CER, was a little bit higher for the unclassified group specifically, so about 62%. And for the rare clusters, it was about 51%. We wanted to drill down a little bit more into this data. And so we broke that kind of agreement and disagreement proportion by CER theme initially. So this is going to look a little bit overwhelming, but I want to draw your eyes to 2 specific portions here. So engagement and communication is going to be the second theme from the top. It's also the second most frequent theme across the entire data set. And regardless of the source of that theme for our subset, from unclassified or rare, all of them were incorrectly disagreed by, were incorrectly labeled by BERT. So despite being one of the most frequent themes that we had, Bert struggled with all of these entries in our subset. As well, I want to draw your attention to reconciliation. There's two interesting things there. Most of the entries were from the rare Bert topics, which, as we know, had a lower proportion of accuracy, but still, almost all of them, about 85% of those entries, Bert was able to agree with them, despite being in kind of the rare Bert topic group. So we're seeing that there's individual relationships within teams between our supervised and our unsupervised method. And this exploration led us to conclude that this kind of unsupervised approach could be used to identify entries that require careful consideration when labeling by the CER or when being modeled by different supervised methods.
So now I'll kind of talk about some of our final conclusions. First, I'd just like to present the results we got for our best models. On OPR, we got an F1 score of 68% for the one versus RAS logistic regression for the top 5 most frequent themes. And for the conditions data set, we had a high F1 score of 85% with Bert on the top 4 most frequent themes. Multi-label classification on text data is a difficult problem. This isn't really a new insight, but what we've identified is that it will likely work better on shorter, more consistent data, such as the conditions data set. Similar models in the future would definitely help streamline the labeling process for CER and improve data availability both within their organization and for the general public's use. So for data sets that might look more like the conditions one, we would definitely recommend they continue looking into this. Some of the limitations we identified during our work for the modeling approach, a big limitation is that it does require pre-labeled data. The reason we approach this problem is because CER has a lot of data that is unlabeled. But for a supervised approach, you do need an amount of labeled data to train your model on. So there will need to be some human labelers at some point in the process. We also would like to note that some of the methods are quite time consuming and computationally expensive. For example, fine-tuning Bert can take a really long time and a lot of compute power. As well, fuzzy matching is a pretty slow process when you're trying to do it on a significant amount of data. Some limitations within our data sets. These are human labeled data, which is something you can't avoid, but it might result in some inconsistency and how different labelers might define a theme or label a certain document. And there were also a lot of duplicates in conditions. And although we did put a lot of work into trying to identify those duplicates, since some of them were like similar but not exact, we might have missed them, and that might have resulted in a bit of data leakage that causes our models to be a bit inflated.
Finally, as mentioned in the beginning, part of our project is to provide some insights to the CER, and here are a couple of recommendations that are based and kind of rooted in our analysis and our results. It's worth noting that between OPR and C and conditions dataset, the database with a shorter text and with a clearer themes outperform the others. So going forward, having either a fewer number of themes or having entries that are labeled at a smaller level could potentially help them use these models in the future and have better results. As we noticed, the more labels there are per theme, the more complicated it is to identify the presence of any individual theme. So reducing the number of themes in any way possible would be incredibly helpful. When we talk with the CER specifically as well, we inquired about the process of labeling themes for any of the data sets that they have, and there wasn't a lot of consistency between data sets. So having more than one labeler per data set, having those labelers be blinded to the source and the context of the data set would be helpful, and having some metrics of inter-rater reliability going forward, so the intra-class correlation and Cohen's kappa, to have an understanding of how these raters are working together and the amount of times that they agree with each other or disagree with each other would be incredibly helpful. For the OPR specifically, there's a lot of interest in doing a second round of feedback, and as revisions are being done currently to the onshore pipeline regulations. And so going forward, labeling maybe at the paragraph level or even at the sentence level rather than at a sentence, and that rather than an answer level would provide them with more data without having to collect anything new, because they would have more precision about all the text that they have. Collecting numerical data wherever possible, so percent agreement and with a specific statement would also give them a lot more useful information in case they want to do surveys in the future. As well, we noticed that the definitions or like the priorities between teams and organizations was different. So reconciliation was the most frequent theme for indigenous folks, and for industry, for example, it was competition. So different stakeholders have different relationships to these themes, and having their input in terms of how the CER relates to these ideas would be helpful, because somebody's definition for environment will differ depending on their context, or somebody's definition for communication may differ depending on their context. As well, we lastly want to mention that the overlap between themes definitely complicated our analysis, but it is a true pattern in the data that exists for a reason. So ideas like reconciliation and gender-based analysis plus, for example, had a lot of overlap between different ideas, partially because they need to be overlapped with a lot of different ideas, because reconciliation should inform your understanding of the environment and communication. In terms of conditions, it's worth noting, as Annabelle mentioned, that there were a lot of instances where there were frequent conditions that were given to companies that had slightly different language, small variations that were filtered out due to fuzzy matching, but having some kind of standard about how to approach specific issues from the CER's point of view would help them have less variation in those entries going forward. And as we mentioned before, there is a lot of labeling consistency as well, because sometimes you would have the same condition being entered more than once, being labeled with a different theme. So it might be a different person looking at the same data. It might be the same person looking at the same data over time. But just having a clear understanding of who's reviewing what themes and when would definitely help them improve the quality of their data. Lastly, we want to give thanks. So we want to give thanks to our partners in the CER, Jose, Susana, Mingji, who always made themselves available to us and answer all our questions, to the wonderful analysts at the DSI, Robert, Raymond, and GE, of course. Thank you for all your support and understanding. And lastly, we want to give thanks to you for your time and for your attention.